So while you're doing the warm-up problem today, talk about the next 2 weeks in L Street. So today we're going to do geometric series. Tomorrow we don't have class because it's a Tuesday. Wednesday we will do applications of geometric sequences and series. Thursday of this week you will have a formative, and the homework packet that I'm going to hand out here in a little bit will also be due. Okay? So you'll have a Thursday assessment week, because Friday is Battle Royale Day, and so we don't have class in the morning, because that's right off the start of at 8 a.m. We go to Battle Royale, and then it usually goes the first 6 months. Well, the 6 months that we had out for free on Friday is for 6 months, so we lose a day, which is fine. Then the following Monday, a week from today, first off, it's March already. This week is March, right? It's March. Anyways, next week, Monday, we'll do infinite geometric sequences and series in one day. And then Wednesday of next week will be your review day. And Thursday, the 7th, is your test. So March 7th will be your sequences and series test. Okay? And then we'll have some activity for you to do on the 8th, which is an independent learning. Okay? So this was a problem like we had from last week Friday. So we use our rule to set up an equation for the first term that was given, and we use our rule again to set up an equation off of the second term. Then it said, or as we said on Friday, then we should take the one with the smaller exponent in it, and we should solve it for g sub 1. In this case, that is the blue one that I'm going to solve for g sub 1. Then I'm going to take that, and I'm going to plug it into my other equation in place of g sub 1. Then we can solve that. And what do we get for r? No. Plus or minus. Y plus or minus 3, and not just 3. No. It's an even root. So that means that we're going to have, because we have 2 different r values, that means we're going to have 2 different g sub 1 values, which means we're going to have 2 different rules for down here. So the first one I'm going to use is I'm going to use positive 3 as my r. If I use positive 3 as my r, negative 3 divided by positive 3, then is going to be negative 1. So that would give me G sub n is equal to negative 1 times positive 3 to the n minus 1 power. Then I have to use negative 3. Negative 3 divided by negative 3 is positive 1. Because my R value, my G sub 1 value was positive 1, I don't have to write it. I wouldn't get it marked wrong if I did write it, but I don't have to put it in. Questions, comments, concerns, clarifications? All good? All right. So today we're going to talk about geometric series. Friday we talked about geometric sequences. Today we're going to talk about geometric series. We'll have sigma notation. Sigma means what again? Sigma means sum. Okay? So we're going to have some formulas going on for the sum of a series. Okay? When we take all of the terms of a sequence and add them up, all that fun stuff. Now, the nice part was, back when we were arithmetic last week and the week before that, we had one formula. Number of terms divided by 2 times the sum of the first term and the last term. It was one formula for no matter what we had. Okay? For geometric, because things are different, things are more goofy with the powers, because we're taking something to a power, we can't just do that. We can't just have one nice, easy one. We actually end up having 2 formulas for it. Each of these formulas will get you the exact same thing. Okay? What I'm going to do is I'm going to give you a couple of, like a minute here to write these down, and then I'll go through it and I'll explain it so that you aren't trying to copy and listen at the same time. So as I said, each of these formulas will get you the same sum total. It's just a matter of what you want to find. Okay? Now notice, in both of the formulas, you have a G sub 1 and you have an R. So no matter what, you have to find these 2. After that, it's all what you want to find. You get your choice. If you're using the right formula, you would have to find G sub n, or the last term in your series. If you're using the left formula, you would need to know the total number of terms. It's 100% up to you which formula you want to use. I do not care. Okay? My go-to jam, my ride or die jam, is the left one. Okay? But sometimes I'm given all of the information in the right one, and I'm just going to use that one. Doesn't matter. Okay? So where do we find all of these informations? Okay? Well, if I'm given a list, okay, most of the time it's going to be the first term in the list, or we could find it right there. Or we could plug in 1 for n on that side. So if you're given the rule, or if you're given a list of a sequence, if you will, a list of terms, you can do one of those 3 things. Okay? If you're dealing with sigma notation, because sigma means sum, how do I find the first term in sigma notation? Let's see. How do I find the first term given sigma notation? By the by, sigma notation hasn't changed from the last time we talked about it in arithmetic. All of those rules still apply. Sigma notation, how do I find the first term? I plug the bottom number into my rule. The next thing that we have to find is we have to find r. Now, finding r is the same, I should say, on both sides. R is the term that has, I shouldn't say term. Immediately regret that. R is the number that has what? What? That's what it is, but R is the number that has what? In the rule. What does R have that no other number has in either rule? It's got what? It's got a power. It's got an exponent on it. Yep. R is the number with an exponent on it. If we're given a list instead of just the rule, how do I find R? So if I'm given a sequence where I've got term after term after term, how do I find R? We said it last week. How would I find R if I'm given it just a sequence? Any term by term right before it? So we take any term, we divide that term right before it. Love it. Yep. Next is our total number of terms. Now, in the left one, okay, you're going to be given that. It's going to say something like, find the sum of the first 8 terms. Okay? Or then that's going to be, 8 is going to be your total number of terms. Okay? Or, if you're given the last term, if it says the last term is G sub 5, okay, and your total number of terms is 5. Okay, so you might be given the last term, and then it's that. Okay? It's hard for me to describe how to find the total number of terms when you're given just the rule, because it's literally going to be given to you somewhere in the problem. Okay? Over here on sigma notation, how do I find n? How do I find the total number of terms? Top minus bottom plus 1. Top minus bottom plus 1. Are you starting to see why sigma is a little bit better, a little bit nicer? Much easier to find everything. Lastly, if we're going to use that other formula, we need to find the last term. Okay? Once again, here, it's going to be given to you, or you have to find it. By plugging in n, if it's here's the rule, or find the first 8 terms of this rule, you've got to plug in 8 to find it then. And you got to find that one. If we're in sigma notation, how do I find the last term in sigma notation? No. Plug the top number in. Yep. Okay. So that's where you find everything that you need to know. Good little review there from Friday too. All right. So here we go. Here is our first sum. We want to find the sum of this geometric series. What do I need first? Or what do you want to find first? Put the ownership on you. What would you like to find first? First term? How are we going to find the first term? What am I going to plug in? Putting in bottom number into my rule, right? Okay. So that's going to be 4 times 1/2 to the 1 minus 1 power. 1 minus 1 is 0. Anything to the 0 power is 1. So 1/2 to the 0 power would also be 1. 1 times 4 is 4. So my first term is 4. What is my R value? We described it as the term with the exponent on it. 1/2 is my R value. Now, you for sure got to find those two things. Now you got to determine, is it easier for you to find the total number of terms, or is it easy for you to find the last term? You make the call. Total number of terms or last term? To find the total number of terms, it's top minus bottom plus 1. To find the last term, it's take the top number, plug it into the rule, find it. Total number of terms is easier. 9 times out of 10, the total number of terms is going to be easier because it's just the top number minus the bottom number plus 1. There are 6 total terms. Now it's just a matter of plugging it into this one. So the sum of the first 6 terms is the first term, which was 4, times my R value, which was 1/2, raised to the 6th power, all over now I'm going to do some math. 1/2 to the 6th power. I got 6 2s. 2 times 2 is 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64. So this is 1/64. If I'm going to add and subtract fractions, what do I have to have? Common denominators. One 64th minus 64 64ths. One half minus 2 halves. We're dividing by a fraction. What are my 3 favorite words? Change and flip. Yep. So I'm going to keep the top fraction, correct? Or in this case, the top multiplication. Like this. Okay. Did I keep it, right? Okay. Yeah. Then I change it to multiplication. And I'm going to change it to, and I flip it to -2 over 1. Agree with that? Now, are you a straight multiply, then a reduce, or are you a reduce, then multiply? Reduce first, okay. Does 4 go into 64? How many times? 16 times, yep. 63 doesn't go into 16, otherwise we would reduce that a long time ago. So I get here that the sum of the first 6 terms was equal to positive 63 over 8. Because a negative times a negative is a positive. 1 times 63 times 63 is 63. 1 times 8 times 1 is 8. Now, let's talk about this for a second. What do I love in life other than my family? Fraction. Leave your answer in fraction. Okay? It's more work to actually put it in decimal form than it is to just leave it in fraction. Because you got to do another step.
What if we find you did like 7 and 7/8?
Yes. Yeah, I would accept it, but improper fractions are cleaner than mixed up numbers. So I get you. Let's see where you're stepping in. I just don't want 7.875. Because then we got, what do I round to? What should I round to? What if I round to this and round to that? And what if I don't know my rounding rules? All that fun stuff. So I have to deal with it in fractions. Okay? You try this one now. So if I use the first one, I would have negative 20 times negative 2 raised to the 15th power minus 1, all divided by negative 2 minus 1. If I used the second formula, I would have negative 327,680 times negative 2 minus negative 20 divided by negative 2 minus 1. Either way, do it fine. Either way, I get the sum of the first 15 terms is negative 218,460. Agree? Questions, comments, concerns, clarification? If you don't put the negative two in parentheses, you get the wrong answer. We'll find the negative. Yeah. Try that one. I get 2,178. In either case. Questions, comments, concerns, clarifications? The homework that I am about to hand out to you will be due this week, Thursday, the day of your assessment this week.